Hi everyone, welcome to the course Optimization Methods. First, let me introduce a little bit about this course. My name is Qingna Li from Beijing Institute of Technology. This is some related information about this course. Now, first we have several reference books. All of them are English. For example, numerical optimization, convex analysis, convex optimization, as well as convex optimization theory. If you have more questions, please contact me by my email or my cell phone, as well as come to my office. Now, let's briefly talk about what about this course. In this course, we will introduce what is optimization, then we will go through unconstrained optimization problems as well as constrained optimization problem. Finally, if we have time, we will talk about some applications and softwares. Now, we start with Chapter 1, the introduction. We will mainly talk about three issues. First is what is optimization. Second is the classification of optimization. And finally, we will introduce preliminaries in convex analysis. Now, let's go to the first part of Chapter 1. What is optimization? So, think about what is optimization. Actually, optimization exists everywhere. For example, people optimize. Why? As long as you have choices, you do optimization. For example, if you got a lot of money, you may do portfolio selection. You try to maximize your return. Meanwhile, you try to avoid the risk. This is a kind of optimization. Moreover, for engineering people sometimes they will maximize the efficiency of the system. They try to select proper parameters in the system so that their efficiency of the system will be maximized. Another very practical example is in people's life that when you go out for traveling, you may choose different paths. For example, if I go to university, I will search on Google Map and they will tell me several paths that I can choose. For example, if I choose the first one, it will return me the smallest time. However, I may use some money because I go by the highway. And the last path actually returns you the longest time. However, you save a lot of money. Okay? So different paths, they have different aims, which is kind of optimization. Now, for nature, it optimizes as well. For example, in physical systems, it is always looking for the minimum potential energy so that it will reach a stationary state. And for isolated chemical systems, it will keep reacting until it reaches its minimum energy state. So both of the two examples show that nature optimizes as well. The final example is that light also optimizes. For example, it's always traveling following the shortest path. Okay, so this is a very common sense. Now, you may ask, what is optimization? Well, there are three key points in optimization. The first key point is objective. So the objective means that what kind of aim you want to achieve. For example, if I do portfolio selection, I may try to maximize my return. So in this case, the profit is actually my objective. Okay, I try to maximize the profit. And in other applications, for example, if you do path selection, then you may try to save your time. In this case, time will be your aim or your objective. So this is the first key point. The second key point are variables, or in other words, the unknowns. That means that the decision that you want to choose, okay, so if I choose this kind of portfolio selection, I will buy several stocks in this way, or I will buy some other shares in other way. So this is the decision variable you want to make. And the third key points are the constraints. Constraints actually is very natural because it tells people that you got several restrictions. So those restrictions are actually constraints. Overall, these are the three key points in optimization. Now, to do the optimization, we have actually three procedures to do that. The first procedure is modeling. That means we have to transfer the real application problem in nature world to mathematical world. So this is the procedure of modeling. The second step is actually we try to solve this optimization problem using some algorithms. And this is actually the main part we are going to focus in this course. Finally, the third part is the checkout. How to stop the algorithms? We need to set up some stopping criterions in order to make the algorithm terminate. So this stopping criterion may have several kinds. For example, if the optimality conditions are satisfied, then we will stop the algorithms. Otherwise, if we cannot reach the optimality condition in finite times, we need to do some sensitivity analysis. This is the three steps when we do optimization. Now, let's pay attention to the first step, the mathematical modeling of optimization. Actually, it is very important to do this first step. Now, mathematical modeling is actually you try to transfer the nature statement to the mathematical statement. So, optimization is the minimization or maximization of a function subject to some restrictions or conditions. And when we do the optimization, we need to pay attention to the following three key points. This is what we have mentioned before. For example, the objective function. So we try to set up our objective function in a reasonable way. What is reasonable way? So this reasonable way is that this f should represent our aim properly. And sometimes, or in a very natural way, this f will be a function value from n-dimensional space to a scalar function, r. This is the objective. And for the second key point, variables, naturally, it will represent as a vector of variables in n-dimensional space. Of course, sometimes this x will be matrix. Anyway, in this class, we will focus on the case of vector. The third part is the constraint. We actually use this constraint function, which also maps the n-dimensional space to the real scalar function. And these restrictions actually represent equality constraints and inequality constraints that the variable must satisfy. So we have putting the key points in mathematical form, okay? So the objective function f, the variable x, as well as the constraint ci. Now, we introduce the mathematical form of the optimization problems. So basically, it takes the following form. We minimize the objective fx subject to some equality constraints and inequality constraints. So you can find the three key points easily. First is the objective here, and the second, you got variables that you want to make decisions here. Okay, so it is below this mean notation. This is the second key point. And the third key point, they appears here. Okay, so you got equality constraints and inequality constraints. We also put the corresponding indices into the capital E and capital I. Finally, we got one extra notation, this S dot T dot here. It actually means that subject to, in other words, these variables x must subject to these constraints here. Okay, so this is the notation we will use quite often in optimization problem. And the final issue is that if you got maximize aim, then we can easily transfer it into minimization problem by just adding a minus term. Then we transfer it to minimization problem. Therefore, in our following lectures, we will always talk about this kind of optimization problem. Now, let's take a look at a simple example. You got some minimization problem with respect to x1 and x2. The objective is you minimize a quadratic function here. And also you got some inequality constraints. So if we recall the three key points, then the first one, the objective we will define as fx, the quadratic term here. And for the variables, we write x1 and x2 in a vector x. Then x will be the decision variables. Finally, the inequality constraints appears two. There are two inequality constraints, and we put them into greater than or equal to 0 form. Okay, so this C1 is actually the minus x12 plus x2 here. Okay, so this is, we add a minus before the constraints to make the constraint here greater than or equal to 0. And the inequality index will be 1, 2, and we got no equality constraints. So the equality constraints here will be empty set. Now let's take a look at what this example tells us. Let's look at this figure and think about what you can see from this figure. Okay? So in this figure, there are actually two types of lines. One type is the dotted line here, if you can see, and the dotted line actually describes the contours of function f. The contours of function f is defined as the set of points for which their function values are the same. These are the contours of function f. Now here, you got three dotted circles here. So the smaller the circle is, the smaller the function value is. Then you can find that if we try to minimize this function value, of course, the minimum will be reached at the center of this circle, right? So this is the optimizer of function f if there is no restrictions on x. However, we got some restrictions, right? We got some inequality restrictions as we mentioned before. So the inequality restrictions actually put the C2 constraints and the C1 constraints here. So the intersection of the two paths will make the feasible region. Okay, so these feasible regions are actually those points that x satisfy the restrictions. So actually, we are looking for the points in this feasible region so that the function value will be minimized. Okay? So compared with the feasible region as well as the contours of function f, then I guess you can easily find the local minimizer. Actually, the minimizer will be reached here, right? X star, this point. The intersection of these contours with the feasible region here, right? So this is a minimizer. Okay, so by this example, we can actually find that if the optimization problem is very simple, then it is possible that we demonstrate it by geometrical graph and we find the local minimizer on hand. However, in real applications, the situation is not that easy. Sometimes you got very complicated functions and you got very complicated constraints. So it is not trivial to solve the problem by drawing the pictures like this. So that's why we need to design numerical algorithms. We need to design the optimization algorithms to find the optimal solution. So this is the main aim of this course. Okay, let's make a brief summary about this lecture. So in this lecture, we introduce a little bit about what is optimization and 3 key points in optimization, and what is the mathematical formulation of the optimization. Finally, we show an example to see how we can get the solution of the optimization. In the next lecture, we will introduce more about optimization. So, this class we stop here and see you next time.